Hello, in this video I'm going to give you some background on the phone number hashing exercise. We'll go over what a hash is and why we'd want to do it, and then a particular hashing algorithm that is used on phone numbers. And so let's talk about the definition of a hash. I mean, you can look it up on Wikipedia, but essentially a hash is a number that is associated with a particular object. And the object could have any particular size, but the hash has a fixed size. A hash is a fixed size identifier that is associated with something else. And many things can have the same hash value. But I mean, you can read and you can see that here. A hash function is any function that can be used to map data of arbitrary size to a fixed size value. So imagine we have a string. We have a whole bunch of different strings. There's some way we can compute a fixed size number that based on the data in any particular string. So we're going to do this for phone numbers. We're going to figure out how to compute the hash for a particular phone number. And you'll see that many phone numbers will produce the same hash code. Why would we want to do this? This was invented in the 1950s by an IBM engineer named Peter Luhn. And it was to facilitate information retrieval. So imagine we have a giant sort of dictionary of phone books and we want to do a reverse lookup. How do we shrink down? How do we reduce the size of the search space for the phone number we want to look up? And his solution was compute a hash for every phone number and then group the phone numbers together by their hash. So if you needed to look up a particular phone number, you'd compute the hash for it, and then you'd say, okay, well, now I can just look in the phone numbers that have those hash codes. And so that's where this comes from. It was designed to facilitate or speed up information retrieval for telephone number reverse lookups. So let's look at the particular algorithm that this IBM engineer named Peter Luhn developed. So we can think of our phone number as 10 digits. And what we're going to do is look at the digits in pairs. We're going to add up each pair of digits to get a sum. But the sum is going to be truncated. We're only going to look at the ones place. So if the sum is greater than 10, we're just going to take the ones place. So if our sum ended up being 12, our hash for that pair would be a 2, right? We're just going to chop off the tens place and keep the ones place. To do that, we will add our two digits together and then mod them by 10. Mod is the percent sign. That means divide and take the remainder. It's like we learned how to do division in second grade. 3 goes into 5, once remainder 2, right? The mod is the remainder. And then that new digit that we gets appended to our hash. So our hash starts out blank. Then we go look at our phone number digits in pairs. We add them together, mod them by 10, and then take that digit and stick it onto the hash. So let's walk through an example here. Here's a phone number, 314-159-2652. So what we're going to do is look at these digits in pairs, compute a hash digit, and append it to our result down here. So let's look at our first pair of digits. We have a 3 and a 1. So we add them together and we get 4. That's our hash digit. And let's take our 4 and append it to our hash. Now let's look at the next pair of digits here in our phone number, and that's the 4 and the 1. So we apply our same step. We add those together, we get 5, and then we append the 5 to our hash code. Let's look at the next pair. This is going to get interesting. So there's 5 and 9. We add those together and we get 14. But remember, we said we're not going to look at the entire, our hash code is just one digit. We're not going to look at the tens place. We're going to mod by 10 and isolate the ones place. So that ends up being a 14. We're going to mod that by 10, and that's going to just give us the 4. And then we're going to stick the 4 on the end of our hash. Now we have the 2 and the 6, add them together to get 8. Mod that by 10, right? We get 8. Append the 8 to our hash code. And let's look at the last pair. 5 and 2, add them together. We get 7. We append the 7 to our hash code. So there is the hash for that particular phone number. And hopefully that was pretty straightforward. But the the key here is that every time you add the two digits together, you take this value and you mod it by 10 to isolate the ones place, and then you add that result onto your accumulated hash code. So that's how you can compute the hash algorithm, right? We just loop through this, looking at the digits in pairs, adding them together, modding by 10 to isolate the ones place, and appending that resulting character onto our hash. So what we've got here is a for loop, really, that we're gonna, rather than having I plus plus, we'll have I plus equals 2. You could step through this rather than going through the loop one at a time. You can go through your loop two at a time, and that way you can look at the pairs of characters. Also, here are some other tips for doing this exercise. You can use the square brackets on a string. Strings support read-only indexing. A string is an array of characters, or can be treated as an array of characters. Back in C, it was an array of characters. So you can use the square brackets on a string to get a particular character out at a particular index. So you can say, my string square brackets I, and then that will return you a character. However, don't try to convert your characters to integers. If you do this, you'll get the ASCII value. So if you have the number 0 and you try to convert that, or the character 0 and you try to convert that to an integer, you're actually going to get the number 48, because 48 is the ASCII value for the character 0. So to get around that little quirk, convert your characters to a string first, then convert the string to an integer. So you could do something like this: convert .2int32, and then notice here we're taking our phone number, that's just a made-up variable name, and we're using the square brackets on it to get out a particular character, and then we're converting it to a string. Remember, everything in C# has a toString function. So what this is doing is converting the character to a string, and then when the string gets converted to a number, that will get converted correctly. So this is kind of the code there for converting any particular character. So what I would do is I would have a for loop, that runs 5 times, and and then I have your loop counter, rather than doing I plus plus, do I plus equals 2, and that way your index will step up by 2 every time, and that way you can look at pairs of characters rather than looking at characters one at a time. So this is a good kind of, it's a good loop array data conversion exercise. I like this exercise. So that's the theory behind the phone number hashing algorithm. The PDF will walk you through how to do this as well, and the directions are repeated in there. So but you have this video to refer back to, and I hope you find it helpful. If you have any questions, just email me and I will be happy to clarify.